Okay, all right. Let's talk about some past paper questions from differentiation, and you can note the paper code and everything. Okay. Now, basically, differentiation is something that we have just started in the last class. So we only talk about this question, and then I'll talk about some more contents and then some more questions. Okay. Now, what exactly is happening in this question? Okay, it says a curve has equation y equals 2x to the power something 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 something. Find the equation of the tangent to the curve at the point this. Now, you guys are not exactly prepared for this question. I would have to explain a few things before doing it, which I explained in the beginning of that class. But since that concept is comparatively difficult, so I would again explain that. So imagine this is a curve. Let's say it's a random curve of this type, okay? This is the curve, for example. And 40 is, let's say 40 is this point, okay? Now you need to find the equation of the tangent to the curve that is tangent at this very point. Now we know that every tangent is a straight line, no matter where exactly it is being made. That does not matter. Wherever it would be made, it is going to be a straight line. What do we need to notice? Okay, what exactly we require for finding the equation of a straight line, right? So we have done that. We need to find the gradient and we need to find a point lying on the line. So if we have these two things, we are able to find out the equation of any straight line. So in case of this tangent line, we have the point, right? The point is 40. 40 is basically the point, this point. And we have a point lying on the line. So that is fine. But how do I find the gradient? Can anyone tell me?
We can differentiate our
Very good.
expression of the
Yes. Excellent. So in the very beginning, when I was talking about differentiation, derivation, every time I was saying it like this, derivative slash differentiation or differential slash gradient slash slope, all these words mean the same, right? And in the very beginning, when I was talking about the gradient of a straight line, I told you guys in case of straight lines, the gradient is same. But in case of a curve, the gradient is changing continuously. So how do we find the gradient of a curve at any point? By differentiating the equation of that curve and then plugging in the x coordinate. So that is
yeah.
something that we have discussed in the beginning as well. Okay. Now, let's talk about the solution. Okay. So I know one thing, that in order to find the equation of tangent, I need to have a point lying on the tangent line. I need to have the gradient of the tangent line, or otherwise I need 2 points lying on the tangent line and I only have 1 point lying. Okay. So what I'll do is I am just going to find the gradient. Okay. So let's do it like this. Gradient of tangent. Now, if you guys remember in the last class, at the end, when I started talking about the gradients, when I started talking about curves, and I told you guys that in order to find the gradient of any point at the curve, you need to make the tangent, and we find the gradient of the straight line or of the tangent line, and whatever gradient we have for that tangent line, that is going to be the gradient of the curve at that point. For example, if I want to find out the gradient at 40, I'm going to make a tangent line at 40 and I am going to find the gradient of this yellow line or tangent line, right? This is something that we have discussed in the last class. So similarly, now if I'm interested in the gradient of the tangent line, I need to have the gradient of the curve at 40. And how do I find the gradient of curve? By differentiation, okay? differentiation of the equation, that is y equals 2x to the power 3 by 2 minus 3x minus 4x 1 by 2 plus 4. Okay, let's differentiate this. So how do we write down derivatives? Dy by dx. Rafa, if you find anything difficult, you can ask me directly because Munja has already covered this with me. Okay, so if you're finding anything difficult, that's completely fine. Acha. Now we are supposed to find the derivation, the derivative or the differential. Both the words mean the same. How do we do it? This number, this coefficient comes directly as it is. This is the power, the old power, the existing power. This power is going to be multiplied at this point. So 2 would be multiplied by 3 by 2. Then I'll write x. Old power is 3 by 2. And then I'll do old power minus 1. Then minus 3x. So again, minus 3 would come as it is. This is 1. 1 would be multiplied by 3. That makes no difference. Old power is 1 minus 1. Okay. Then again, minus 4 would come as it is. This power is 1 by 2. This 1 by 2 would be multiplied with 4. And x power 1 by 2 minus 1. And what about this positive 4? What is the derivative of this positive 4?
0.
Very good. It is 0 because now we know that if we have any constant, if we are going to differentiate any constant, the derivative is going to be 0. Okay. Perfect. So let's just simplify this. Now we know that the differentiation or the derivative is basically equal to 3 into x power 1 by 2. Then we have minus 3. Then we have minus 2x power minus 1 by 2. Any difficulties with this?
No.
Okay. Now I'm going to write this derivative once again neatly. Dy by dx is basically equal to 3 root x minus 2 divided by root x minus 3. Okay. Next, this is the derivative. This is the differential. What is the gradient of the curve at 4, 0? This is what we tried doing. We wanted to find the gradient of the curve at 4, 0, just so I get the gradient of the tangent line. So I told you in order to find the gradient of the curve, we need to differentiate that. But gradient is supposed to be a number, right? Gradient is not an equation with some variable. So if gradient is supposed to be a number, what next should I do?
You plug in the x coordinate.
Very good. Since I want the gradient at 4, 0, I need to plug in x equals 4 at this point. Okay. Since I am supposed to find the gradient at 4, 0, so I need to plug in x equals 4 at this point, and that is going to give me 3 into 4 root 4 minus 2 divided by root 4 minus 3. Okay. And this is going to give me 3 multiplied by 2 minus 2 divided by 2 minus 3. Okay, now this is the first choice and it could be negative 2 as well. Let's find the solution from this first. So 2 and 2 would be cancelled. This is if root 4 is giving you positive 2. Okay, and this is going to give you 6 minus 3, that is 3. Okay, and if we consider,
Miss,
yes,
this 2 and 2 cancel out, so minus 1 is
yeah,
left. Right?
it's 1. Yes, it's minus 1. Yes, you're right. This is minus 1. And this is also minus 1. So this is going to give you 2. Just give me 1 second. Yes, that is correct. Okay. So basically we had 3 multiplied by root 4. minus 2 divided by root 4 minus 3. Upon cancelling this, we got minus 1. And for now, we are considering that root 4 has given us positive 2. Okay. And that is finally going to give us 2. And if we consider that root 4 is negative 2, so that would give me, let's do that here, 3 multiplied by negative 2. Then we have minus 2 divided by minus 2 and then minus 3. So this would be cancelled and this is going to give me positive 1, minus 6, positive 1, negative 3. So in total, it is going to give me negative 8, right? So this means,
Miss, why did we do this step?
because when you will take root 4 can be positive 2, root 4 can be negative 2, right? It can be both. This is
Miss,
how we usually do. Yes?
but when we did like 3 divided by 2 minus 1, and then it came like exactly like a positive value, like positive 1 over 2. So why are we like considering that?
You are saying when we have considered,
Like when we like took the 3 over 2 from the power 2 and multiplied it with the 2, like in the above um, solution, we also did like 3 over 2 to the power of minus 1, right?
this
So
one?
like, yes, miss.
Hmm.
So like, aren't we certain that it is like positive 1 over 2?
Yes, 1 over 2 is positive, certainly. No, like whenever we are taking the under root of any number, let's say if we have 64 here, we write it down as plus minus 8. If it's 4, we write it down as plus minus 2. If it's 16, we write it down as plus minus 4. I'm talking about this thing. Whenever we are taking root of any number, we always consider both positive and negative values for that, right?
Mm.
Okay.
Yes, miss.
So that is why it is certainly positive root 1 by 2. Like this part is positive 1 and then this part was with the negative power. But the power is irrelevant. That is not important. The power is just going to decide if this would come in the numerator or denominator. That is irrelevant. But whenever you have a number inside under root, you are going to consider both the scenarios, right? It could be positive as well, it could be negative as well. So this is what we have done.
Okay, miss, got it.
Okay, very good. So it's going to be root 4 and now root 4 is going to give me a negative 2 and then again a negative 2. Negative 2 and negative 2 would cancel to give me a positive 4. This would give me negative 6 plus 1 minus 3. This would be negative 8. Okay, so both of these could be the gradients at the point 40. Now it's very simple. You need to write both the solutions in the final answer, okay? And I'll just do it for one. The point lying on the curve is 40. Now I know that it's y minus y1 equals m into x minus x1. What is this? This is basically the equation of line. Because if you remember, what was the question? The question was to find the equation of the tangent, right? So you need to find the equation of the tangent line. I know that this is how the equation of tangent is, and this made me know that I need to have the gradient of the tangent. And now that has turned out to be 2 slash negative 8. So let's consider 2 for this, and you can automatically do it for negative 8. And the point lying on the curve has coordinates 4, 0.
Yeah.
So if I find the equation, it is going to give me y minus 0 divided by y minus 0 equals m is 2, x minus 4. So it's y equals 2x minus 8. And this is going to be the answer. Yes. Is it okay?
Yes, ma'am.
Yes, Rafi?
Yes. Yes, can you show the paper?
Yes. Okay.
Okay, miss, done. So like whenever there's going to be like positive 1 over 2, so we will be writing both positive negative roots, right?
Positive 1 over 2 in the power does not make any difference with the logic behind roots, right? Positive 1 by 2 or negative 1 by 2 is just going to decide if this x is going to stay in the numerator or denominator, okay? Please remember this. The power, if the power is negative, the thing is going to go to the denominator. If the power is positive, it would stay in the numerator. That is it. Whatever we are doing with root x has nothing to do with positive negative power. Okay,
Okay, Miss.
if you say it that like that, then this means that here I need to write down positive 2, and for this one I need to write down negative 2, right? But that is going to be wrong. This is not the concept. The concept is that whenever you have a number inside root, you need to write down both the positive and negative concepts, right? And I told you this thing that it's only for even powers. Like if you have uh, cube root of 8, you would not write down positive negative 8. You would only write down positive 8. If you have cube root of negative 8, you will only write down negative 2, right? This is something
Yes,
that we have already discussed. Okay. Are you sure that this is clear?
yes, Miss. Got it.
Okay, perfect. Okay, so let me just switch back to the PDF because now we need to talk about a few more concepts and then we will talk about some more questions because the differentiation that we have discussed so far is not very straightforward. Even this is one of the applications, so that is why you guys would have found it comparatively difficult. But for now, we need to talk about a few more things before doing questions. Okay, let's do one more question from the book that is related to the similar topic. And let's see if you guys can do something about it or not, okay? So the question is again very, very similar. And it says, find the gradient of the tangent to curve y equals x into 2x minus 1 into x plus 3 at the point 1, 4. Now I need to explain two things out of this. The question says, find the gradient of the tangent to the curve y equals this at 0.14. Now what we know is that this is going to be a cubic curve, right? Certainly, this is going to be a cubic curve. And if I just talk about a random cubic curve, let's say if it's something of this type, and let's say 1, 4 is somewhere here, for example. So the gradient of tangent means that I am going to have a line at this point and I need to find the gradient of this line. And how do I find the gradient of this tangent line? By finding the gradient of the curve at this point. And how do I find the gradient of the curve at this point? By differentiating this equation and then by plugging in the x coordinate, right? So I know one thing for sure, that the curve is y equals x multiplied by 2x minus 1 into x plus 3. How do we differentiate this? Have we studied a rule, something where we have things being multiplied with each other? Like we know if something is being added or subtracted, we can just deal them separately and we can find the gradient. For example, if I talk about this question, so in order to differentiate this, we differentiated this part, we differentiated this part, this part, this part, all the parts separately, and the answer at the correct was the overall derivative of the equation. But what about this? When things are being multiplied, how do I find the derivative? Now we have not studied any rule for this. This means we need to use our old knowledge and still differentiate it. So what I can do is I can just rewrite this equation as y equals x multiplied by 2x would give me 2x squared, and x multiplied by -1 would give me minus x, and then x plus 3 would come as it is, and then this 2x squared would be multiplied by this x and it would give me 2x cubed, and then this 2x squared would be multiplied with this 3 and it would give me 6x squared. Then this minus x would be multiplied by x and it would give me minus x squared, and then this minus x with 3 would give me minus 3x. Okay, so 2x squared multiplied by x would give me 2x cubed, 2x squared with 3 would give me 6x squared. Then we have minus x with x, that would give me minus x squared, minus x with 3 would give me minus 3x. Let me just simplify this. 2x cubed plus 5x squared minus 3x. Okay, this is basically the equation of the curve. It is still the equation. This was also the equation. This is also the equation. I have not differentiated it yet. I have just simplified it. And why have I simplified it? Because now I know how exactly I can differentiate it. At this point, I was not sure about it, right? At this point, we do not have any rule discovered so far where we can, like, obviously we have a rule so far, but we did not talk about that rule yet, where we deal with the derivatives of things that are being multiplied to each other. Okay, so we have only studied a rule where things are being added or subtracted, and we know that for that case we differentiate all the terms separately. Now we can find the derivative. So dy divided by dx is going to be, yes, I'll wait at this point. Please tell me the derivatives, whatever you think it would be.
6x squared plus 10x minus 3.
Very good. Excellent. That is correct. Okay. And what is going to be the gradient of the tangent at this point? Sorry.
That is going to be
Is 13.
Yes. Very good. Okay. So we have a curve. We were able to differentiate that, and that differential is just a differential derivative. In order to find the exact gradient or the slope, I need to plug in the x coordinate of the point. This is the x coordinate of the point, right? It's 1. So 6, 1 squared minus 10 into 1 minus 3 is going to give me 13. That is right. This means that 13 is basically the gradient of the tangent at 1, 4, right? Any difficulties with this?
No, miss.
Okay. All right. Then we have this important part as well. Okay. Achha. Let me just open the past papers. Okay. After this, we had this question. No, okay. This part would be done later. The first one. The second one can be done. Okay. The third one, fourth one can also be done. Okay, perfect. Okay. Acha. Let's talk about some more questions and one very small concept as well. Okay. Now this is the second question, or basically the 8th question of this year. You can just note the details. It's again for 2017 exam. And the question says, a curve is such that dy by dx is minus x squared plus 5x minus 4. Okay. Forget the first part. We have not discovered stationary points yet. We'll talk about that later on.
Miss, we can just make dy upon dx 0, right?
Yes, very
sentence,
well done.
right?
Excellent, excellent. So this means that you know this, so let's try doing it as well because we have already discussed this with Munya. Okay, now we know one thing since you already have some basic idea. If this is a curve, this is its maximum point, not only the maximum point, the stationary point as well. If this is a curve, these are basically the stationary points. Stationary points are the points of the curve where the gradient is zero. And why is the gradient zero? Can anyone tell me?
Miss, the line is completely horizontal.
Very well done. Excellent.
Yeah.
So if I make a line at these 2 points, very good. That is basically going to be a horizontal line. And we know that horizontal lines have no slope, zero slope. So the concept is that stationary points basically have the derivative dy dy by dx equals 0. Perfect. You already have the derivative and you have been asked to find the stationary points. So how do we do that? We are going to plug in this as 0. So minus x squared plus 5x minus 4 equals 0. And next I can rewrite it as x squared minus 5x plus 4 equals 0. You read two numbers such that when you multiply them, you get 4. When you add them, you get minus 5. So that is x squared minus x and minus 4x plus 4 equals 0. I'll take x common, x minus 1, minus 4 common, x minus 1. And finally, it is going to be x equals 4 and x equals minus 1. We can certainly have more than two stationary points, right? For example, if let's say your original curve is a cubic curve, and it certainly would, we'll talk about that later on, just derivative. But if the original equation is cubic, it is going to have two stationary points. This is the first stationary point, this is the second one, right? So this is going to be your answer. Yes, Mundia, any difficulties with this?
No, ma'am, thank you.
And what about you, Rafe?
No, miss.
Okay, very good, perfect. Okay. Let's talk about the next part. Okay. Now it says obtain an expression for this. This is basically the second derivative. Very good. It is the second derivative, but it's nothing new. If you have y, the first derivative is dy by dx. How do you get this? By differentiating y, right? By differentiating this, you are going to get the second derivative by differentiating this. That is it. This is the only concept. Okay. So in order to find the second derivative, you are supposed to differentiate the first derivative. Okay. So we'll talk about this part in 1 minute because you guys are already familiar with this. But before that, let's talk about this thing because the question says obtain an expression for d2y divided by dx2. It's not read this way. It's basically the second derivative of y with respect to x. In order to find the first derivative, we differentiate the original equation. In order to find the second derivative, we differentiate the first derivative. What is the first derivative? That is already given, right? It's minus x squared plus 5x minus 4. So let's write that down. Dy by dx is basically minus x squared plus 5x minus 4. This is the equation of the derivative. Now we need to find the second order derivative. Second derivative or second order derivative, that means the same, is basically written this way: d2y by dx2. You don't read it like this. We read it like this: second derivative of y with respect to x. And this is equal to, this number is 2. It is the power, it would come here. This would become minus 2 and x to the power 2 minus 1 plus 5 multiplied by x, and in the power we would have 1 minus 1. And for minus 4, it is going to be 0 because 4 is just a constant number. And upon simplification, I am going to get minus 2x plus 5. So this is basically the answer for the second derivative for d2y by dx2. Yes, Rafi and Munja, any difficulties with this?
No, miss.
Acha. Rafi, are you familiar with the nature of stationary points and all that?
Like if it is a maximum or minimum,
Yes.
right?
Yes.
Yes, miss.
Okay, perfect. So this means that we can also do this part. Now, exactly the way you said, it says, hence or otherwise, find the nature of each of these stationary points. Now we got two stationary points. And in order to find the nature of stationary points, we need to use the second derivative. Okay. Now, yes.
Sorry. On the first, differentiation,
Mm-hmm.
is it supposed to be minus 2x plus
This line,
yeah.
one
If
second.
we differentiate 5x, it just gives us 5 here. Then when we come to the second differentiation, I think that 5 would disappear.
No,
So to
no,
define,
1 second. This is the first derivative. Okay, this is the first derivative. This first derivative has 5x. I'm just finding the second derivative. If I have 5x and if I'm differentiating 5x, that is going to give me 5, right? I'm not
Oh,
differentiating 5. I'm differentiating 5x. Okay?
okay. Sorry, what can I read the first question?
Yes.
The first part, maybe that's where I got it wrong.
Yeah. Sure.
Okay, thank you.
Okay. So dy
Okay.
by dx was given basically. The original curve was not given. Very good.
Okay.
Okay. So, acha. Now you need to use the second derivative in order to find the nature. Now the rule says, I'm just writing the rule here because we have not discussed this officially. But if you guys are already familiar with this concept, that's fine. The rule says, if the second order derivative is less than 0, this would imply a minimum point or maximum point?
Maximum.
Maximum. It used
Yeah.
to be other way around, okay? Whenever
Yeah.
your second order derivative is negative, that very stationary point is basically going to be a maximum point. And then it is, if the second order derivative is greater than 0, then it is going to be a minimum point. So just remember this.
Okay.
It's like
Hmm?
will we be discussing the logic behind this, like in the
Yes.
future?
We will talk about that. We will talk about that. Okay. There is certainly a logic, and we'll talk about that as well. Okay. Acha. So if basically the derivative is, if the second derivative is negative, it's maximum. If the second derivative is positive, it's minimum. Now you have the second derivative. We have 2 points, basically two stationary points. And it's x equals 4 and x equals 1. These are just the x coordinates because the question was about the x coordinates only. X equals 4 and x equals 1. So using x equals 4, we are going to get minus 2 into 4 plus 5, and that is going to give me negative 3. What does negative 3 imply? A maximum point. This means that at x equals 4, we have a maximum point, and at x equals 1, it would be positive 3. So that is going to be a minimum point. Okay. So this is basically the idea. And yes, we will certainly talk about the logic as well. That is a bit complicated, but it is fine. Okay. I agree that that is important. This is a good question. We'll certainly talk about that. So for now, this is something that you guys already knew. That is why I explained this part. But otherwise, I only planned this much. Okay. All right. Munja, are you clear with the concept? Tell me please quickly.
Yes, ma'am. Thank you.
Okay, well done. Acha. The third part says, given that the curve passes through the point 6, 2, find the equation of the curve. Now, we can't do this for now because this is related to the next chapter, that is integration. But what is the idea? The idea is that this time around we have the derivative. We have dy by dx, and you need to go back to the curve. Usually, you have the equation of the curve and you need to differentiate that. This time around, you have the differential and you need to find the original equation of the curve, right? So this is basically related to another chapter where the ideas are just like differentiation, but they are opposite, right? They are opposite. So that is basically going to be the next chapter. And for now, that is it for the past paper questions, okay? I am going to switch back to the PDF. Okay. Next, I need to talk about another concept that is basically called the chain rule.
Okay.
It's basically the second section. Although, since we have done some past paper questions, I was able to see that you guys know more about it. But still, officially, it's basically the second unit, the chain rule. Now, what is happening in the chain rule? I'll tell you. So far we know how to find the derivative of expressions like, one second, like y equals x squared plus 2x plus 1, right? But what if I write down y equals x plus 1 whole squared? How do we differentiate this? This thing is exactly the expansion of this, right? So we know how to differentiate this. Why? Because we have studied the rule. The rule was that if things are being added or subtracted, you need to deal them separately, differentiate that, and overall that is going to give you the entire derivative of the equation. But what if I say I don't want to use this, I want to use this then? Then basically we need to talk about another rule, and that rule basically is for brackets. Okay, now the rule is, let's say we have y equals 8x plus 2 power 5. Okay, now you can't expand it. Like we can expand this as well. We can also expand this, but the expansion of this is going to be very, 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 very difficult, right? So since that is difficult, I need to differentiate this directly. So I will have to use the chain rule. Now for the chain rule, what do we do? Just consider the inside part equals to some other variable, right? Just hold on for some time, it would get clear. It's equal to u. And now I can assume that it is y equals u power 5. And now I certainly know how to differentiate y equals u power 5, right? Dy with respect to u is basically going to be, this 5 would come here and it would be u with the power 4, right? This is basically the derivative of y with respect to u. But we don't write it down this way. We write it down as the derivative of y with respect to x. Please pay attention. It is going to be clear in 1 minute. It would be clear in a minute. And that is basically equal to, and that is it. This is your chain rule. In order to remember this, although this logic makes no sense in this case, but just to remember this, the chain rule says dy by dx, you need to find dy by dx, and in this case, otherwise we don't need chain rule. Otherwise we are able to differentiate it directly. But if you have something inside brackets, we'll be using the chain rule. And how do we use the chain rule? Dy by du multiplied by du by dx. So just to memorize this, you can think about it this way, that dy by dx is basically equal to this part, because if you cancel du by du, you would get dy by dx. Although mathematically you can't cancel this, and that is certainly wrong, okay? But just so you guys are able to memorize this, only that is why I am using such notation. Okay, now this is the chain rule. Let's do this question using chain rule, and then things would make more sense. So my end goal is to find dy by dx for this scenario. For this scenario, right? Where we have 8x plus 2 whole power 5. Whatever you have inside the brackets is basically equal to u. So dy by du is basically the differentiation of y with respect to u, this equation, and 5 would come as it is. It would be u power 5 minus 1, that is 4. Same rules. And next we have du by dx. So how do I do that? I know that u is basically equal to 8x plus 2. So how do I differentiate this? It's again the same thing. 8 would come as it is. The old power is 1. 1 would be multiplied by 8. It would remain 8. And x would become 1 minus 1. And plus 2 is basically going to be 0, because the derivative of any constant is 0. And this is going to give me 8. So what does this imply? This means that dy by dx is basically equal to dy by du, that is 5u to the power 4 multiplied by du by dx, that is 8. And lastly, I'm going to plug in the value of u, that is 8x plus 2. And this would become 40 multiplied by 8x plus 2 to the power 4. And this is the answer. Yes, any difficulties with the idea?
No, miss.
Munja, what about you? Is it because you already knew this?
Yes, ma'am.
Miss me?
But
Yes.
practice it very often.
Miss, no, miss, I didn't know this.
Acha, okay. And what about you, Munja?
I do practice very often.
Okay.
Yeah.
Yes. Okay,
But,
perfect. So this is basically the chain rule officially, right? This is just the formula, and just for the purposes of completing the entire thing and for the sake of completion, I've discussed this. Tomorrow, we are going to talk about some past paper questions where I would not be writing it down this way. I would be differentiating it directly without considering the chain rule, just because now we know the underlying logic, we can directly differentiate it. In the exam, you're not supposed to write it down this way. U is equal to 8x plus 2, dy by du is this. No need to do it that way, okay? You will see that this question would come for 3 marks or for 2 marks, and then you would understand that the differentiation can be done directly as well, okay? It's your choice. You can use the chain rule, or you can use the idea behind the chain rule directly, but we'll talk about that in the next class, that is tomorrow, okay?